discuss another good method, which is a tree method. So what this method says, any tree with any number of branches will be a statically determinate, means the static indeterminacy of a tree is 0. But the important point is that this end, means the root or the support of the tree, should be fixed. So we need a fixed support, and a cantilever, which is a tree with many branches, will be a statically determinate having indeterminacy 0. Now it is also important that in no tree you can find there is a closed loop, means a tree cannot be like this. Okay, so you have to take care that every tree the branches should be open. I will explain you how to do it. Now let us see. I have one structure, this one. Then if I try to solve by our conventional method, then what will I get? I will get 3 here, 3 here, 6, and then no closed loop, only u equals to 3. So 6 minus 3 is 3. Now if I don't want to do this calculation, then I can do it directly by tree method. So if I make one cut here, then that makes 2 trees, one this and one this. So to make 2 trees I require one cut, and one cut gives static indeterminacy of 3. Okay, so what is the static indeterminacy in this case? In this case the static indeterminacy will be 3 directly, because we make one cut to make the trees. How many number of trees we make, it is immaterial. The important part is how many cuts we do. Now let us see another problem in this. If you take this, then I require 3 cuts to make it a 2 trees. Okay, so what will be my cut tree looks like? So these are my 2 trees. So how many static indeterminacy now? So the static indeterminacy will be 3 cuts. So it will be 3 into 3, 9. But there is one issue also, which is this is hinge. This is not fixed. So to make it fix, I need one more force. So that will reduce the static indeterminacy, and I will get static indeterminacy as 8. So keep in mind that the base should be fixed, and the number of cuts required to make it a tree multiplied by 3 will be the static indeterminacy. This is a very powerful method. Initially it may look a little bit odd, but later on you will find this very powerful. Now let us take this question. So how many cuts I require? One cut here and one cut here, and then it will become 3 trees. With 3 trees I have to reduce -1 here. So 2 cuts, so 3 into 2, 6 minus 1, 5 is the answer. Now if you see this question, then this is also a tree with 0 stem. Okay, so how many, and this is also this is a horizontal tree. Clear? So how many cuts I require? to make trees, one cut here, one cut here, one cut here, and one cut here. So this becomes one horizontal tree. This becomes one vertical tree with two branches. This is one vertical tree with two branches, and this is only a branch tree, no stem, and this is a horizontal tree. So how many cuts? Total 4 cuts. 1, 2, 3, and 4. So how many static indeterminacy? 3 into 4, 12 is my static indeterminacy. But now you see, this is not fixed, so minus 1. This is also not fixed, so minus 1. This is roller, so minus 2. Okay, so what is my static indeterminacy now? I have to reduce minus 4. So 12 minus 4, that is 8. I have also solved the same question using our conventional method of E, U, and R. So you can use that also. Now let us take this question. So in this question, I have how many cuts? 1, 2, 3, 4, 5. You can see if this is a tree, then I have to make one cut here so that no closed loop is formed. Then I bifurcate it into two trees like this. So I have total 1, 2, 3, 4, 5 cuts. So I get 15. But this is not fixed, so minus 1. This is also not fixed, so minus 1. So 13 is the answer. But if you do by our conventional method, then what is E? E is 2 here and 2 here. So 4. U is 3. So 4 minus 3 is 1. Now how many closed loop? 1, 2, 3 and 4. So 3 into 4, 12. So what is my static indeterminacy? It will be 13, same as here. So whatever method you find, you can use it. I like tree method, so I mostly try to solve by tree. But if you like this method, then you can use this method also. Now let us take another problem. If you take this problem, and I will try to solve by tree method, then I require 4 cuts to make it a tree. So if 4 cuts, so 3 into 4, 12. Now this is not fixed, so minus 1. And this is an internal hinge. The same principle will act here also. So there are 4 members joining. So 4 minus 1, 3 is my additional equation. So how much I get? 8. Now see this question. In this question also, if I require to solve it by tree method, then this is one tree with no stem, only branches, one branch here, one branch here. This is one tree and this is one tree. So how many cuts I require? I require 2 cuts. So 3 into 2, 6 are the cuts. Then minus 2 because this is a roller, minus 2 because this is a roller. So what is the static indeterminacy? 2. Now if you see, if we do it by our normal method, then E3, 1, 1. Minus 3 because of U, so E becomes 2. There is no closed loop in this, so I becomes 0. R is 0, no additional equation is there. So what is the static indeterminacy? Static indeterminacy is 2. Now let us take one very good question. It is a ball question. So let us see what it is. If there is a ball, round ball, with 2 bracings, okay, which you might see in a gym or somewhere. It is placed on a floor without any fixity at bottom. Okay, then what is its static indeterminacy? So if you see, I solve by first our conventional method. So if you see, then its external indeterminacy is minus 3 because there is no reaction. So 0, U is minus 3. So what we get? E equal to minus 3. Now we have 4 closed loops. So my internal indeterminacy is 12. So what is my final indeterminacy? My final indeterminacy is 12 minus 3, 9. But if I solve with tree method, then there will be only one tree, which is which I will get by 4 cuts. One cut here, one here, one here, and one here. So 4 cuts, so it becomes 12. No fixity at bottom, so -3. So how much I get? I get 9. Now let us take another problem of link. If there are two beams joined by a link, CD is a link, so link can take only one axial force, it cannot take the vertical load. Okay, so if you take this, then how many additional equation I am getting? I am getting additional equation 1 here and 1 here. And what is that? The moment at this and this point is 0. Okay, so if this at this point moment is 0 and at this point moment is 0, so I get 2 additional equations. So my R becomes 2. Same, and rest is same. How much is E? E is 2 here, 1 here, 1 here, and 2 here. U is 3. So what I get? I get E equal to 3. So 3 minus 2 is equal to 1. I is 0 because no closed loop is formed. Now in the last we discuss the stability of structure. So how to check the stability of a structure? It is very simple. If you have to check the stability of a structure, then either you find the static indeterminacy, but sometimes the things are very complicated and we are unable to find static indeterminacy directly. So we can use one more thing, which is if the reactions are concurrent, means they meet at one point, then that structure will be a unstable structure. So in this is an unstable structure because the reaction is concurrent. Similarly, if all the 3 reactions are parallel, then for any general loading, this becomes a statically unstable structure. For any inclined loading, this structure will move on these 3 rollers. But I want to make it one thing clear here, that if I have a vertical loading, then there is no issue. This is a stable structure. So sometimes in engineering services, I have seen the question in which the examiner has given a particular point that the reactions are vertical. If the reactions are vertical, then this structure is a stable structure. But if it is having a generalized loading, then this structure becomes unstable. So please keep a watch that what the examiner is asking. Now let us take the space frame. Space frame, if you have understood 2 dimension, then for 3 dimension space frame is very easy to understand. The thing is, for fixed support, now I have 6 reactions, which are Fx, Fy and Fz, Mx, My and Mz. Okay, for hinges, these all 3 will become 0. So I will get Fx, Fy and Fz. So for hinge, I have 3 reactions. For a fix, I have 6 reactions. Now there are roller can be of 2 types: 2-side roller and 1-side roller. 2-side roller means roller can move in this any 2 direction, perpendicular direction. Okay, so if we take perpendicular to the plane also, then this is a 2-way roller, means it can move in this direction and in this direction. So, and what will be the reaction then? Then I will be having only one reaction for this. Okay, but there can be a 1-side roller, which means it can move only in one direction. In 3 dimension, it is able to move in only one dimension. Then I will be having only one reaction. So this is my 1-side roller because it can move in only one side. Now if you use tree method, then one cut will provide 6 equations, sorry, 6 static indeterminacy. We will see it in the question. Second, for internal indeterminacy, one closed will provide now 6. So one closed loop in the 3 dimension will provide 6. So my internal indeterminacy becomes m into closed loops. So m will be now 6. Similarly, if there is an internal hinge, then how many additional equation I will get? I will get additional equation as 3 multiplied by n minus 1. Now what is n minus 1? N minus 1 is the number of members, n is the number of members joining, and 3 is my standard value which I have discussed in the 2 dimension. There 3 was 1. Okay, now let us see the one question. See this question. So what is my E? So if you see this, then E will be 6 here, 6 here, 6 here, and 6 here. So how much? I get 24. Now what is my U? U is 6 now. For 3 dimension, U becomes 6. So E becomes 18. Now I have one closed loop. So one closed loop gives 6 into 1 static indeterminacy. So I becomes 6. So what is the total static indeterminacy? It becomes 24. Now let us take another problem. In this problem, we have same but with 2 internal hinges. Now if you take internal hinge, then at this point 3 members are connected. So how many additional equation I get? I get additional equation as 3 into 3 minus 1. At this point only 2 members are connected. So I get 3 into 2 minus 1. So how many additional equation I get? I get additional equation as 9. Now if we try to solve by tree method, then the fundamental will be same. I have to make 4 cuts to make it 3-dimensional trees. So how many I will get? I will get 4 into 6. One cut will be providing 6 additional 6 static indeterminacy. So 4 into 6 becomes 24. Now here same thing, additional equation is same as we discussed right now. So what is my static indeterminacy? It is 50. Now let us take one more problem. This one. In this, if you do by conventional method, then for F3, this is a hinge. So I'm sorry. I'm sorry. So this is 6. This is 6. This is 3. And if not given, you take it as a two-way rule. So I get 1. Okay, I only get one reaction. So what, and 6 is my U. So how many external indeterminacy? External indeterminacy is 10. What is internal indeterminacy? One closed loop here. So it will be 6. So what is my total indeterminacy? 10 plus 6, 60. Now if you try to solve it by tree method, then you have to make 4 cuts. So 4 cuts will give you 24. Now here you have minus 5 and here you will have minus 3. To make it fix, you need additional 3 and in here you need additional 5. So how much you will get? 60. Same for here, you can practice it, and if you have any doubt you can WhatsApp me on my mobile number just given at the end of this video. So you can solve these things and you can download the notes from my website rcaonline.co.in. So friends, this is all about static indeterminacy. I will be taking up the second part of this lecture series, which will be kinematic indeterminacy. Thank you for watching this video. Feel free to WhatsApp me on this number for any doubt or explanation. Give your thumbs up if you like the video and subscribe my channel.